Now we have to discuss center of mass. It's a very good concept. In fact, this is human, you can say, innovation. When the human being was born, when mankind came into existence, people might not be having any knowledge of center of mass, right? So it was human innovation which came into picture when we started studying the natural phenomena. See, it is very useful when you want to study motion of system as a whole. We are into classical system, that is system of particles having large inertia, right? So when the system of particles having large inertia, sometimes we come across system of particles where we are not interested in motion of the individual particles, but we are interested in the motion of system as a whole. Like, suppose we are interested in, say, I take an example of, say, Jupiter with 12 moons. As far as I remember, Jupiter has got 12 moons. So I'm interested in motion of Jupiter plus 12 moons with this system of particles. If I am interested in this system of particle, I am not interested in the motion of a single moon or motion of individual moon. In that case, if I am interested in motion of the system as a whole, then center of mass becomes very useful. Center of mass won't be very useful if you want to study the motion of individual particles. May not be very useful, but it becomes extremely useful when you want to study motion of the system as a whole. When you want to study motion of system as a whole and not motion of individual particles, right? If I interested in motion of system as a whole, this becomes extremely useful. Okay, so center of mass is more a statistical concept, and it's more a kind of statistics. Have you ever do you know what is meant by average? What is meant by average? It's kind of average basically. What is average? When do you feel the need of average? When do you feel the need of average? Say, if you are in a semester, and if somebody asks you what your result, what do they ask you? Do they ask you about marks of individual subject? If suppose I want to have an idea of your academic performance in graduation, say. If I want to have an idea of your overall academic performance in graduation, what will I ask you? Will I ask you the marks in each subject, or will I ask you average? I'll ask you an average. I won't be interested in. I'm not interested in how you have done in the individual subjects. I am interested in what is your academic performance? What is your overall academic performance? If I am not interested in the marks of your each subject, I am interested in overall academic performance, right? If you say, suppose that you have scored, say, 75% marks, it means I'll have an idea that more or less your marks in all the subject will be here and there about 75. If it is 18 some subject, it will be 17 some other, right? So 75% marks gives you a fair idea of what can be the overall marks, what can be the overall distribution of marks in the subjects. The marks will be here and there about 75. So 75% is the average. So average gives you, I can say, a measure of central tendency. It gives you an idea that around what value the data are distributed. 75% marks means the marks in individual subjects will be distributed. Marks in individual subject will be lying here and there about 75%. That is what average means. That is what average mean, right? So we have the need of average when we are interested in overall academic performance, overall information. We are not interested in each data, we are interested in average. Suppose a principal of a school is interested in overall academic performance of his school. What he will be interested in? He won't be looking for marks of each student. He'll be looking for average marks which a particular group of students have scored. Like say 10th board exam. We have in India 10th board exam. Suppose in a school, say 400 students sat for this 10th board exam. Then if a principal want to know the overall academic performance, what he will do is he'll get the average of the marks of each students, right? Average of the average marks of the whole school will be sum of the average marks of each student by number of students, right? This is how the average is calculated. So average becomes very useful when you are interested in motion of the system. You are interested in the system and not its constituent particles, right? Suppose my marks was in 10th class, my marks was say 89.8%. I'm disclosing some information about myself. 89.8%, and in 12th I had 79.4%. It decreased, but then I qualified IIT JEE in first attempt. And then in B.Tech my marks was just 7.4 out of 10. 7.4 is CGPA out of 10. It's not like 74%, it comes to be 68% basically, but let's assume it to be 74%. So if somebody can see these marks, he can get an idea that the overall academic performance of the student have fallen. Means he was more intelligent in 10th class, become less intelligent, become even less intelligent in B.Tech, right? So this is how the overall performance of the particular person is mine basically. How my overall performance moved with respect to time. This was my performance in 10th, this was my performance in 12th, this was my performance in B.Tech. So this is how my academic performance moved, my academic performance varied with respect to time. So you can see how powerful the concept of average is. How powerful the concept of average is. Average is making your task easier. You are not interested in what was my marks in Hindi, English, Sanskrit and science, maths. You are interested in my academic performance, so you will be going for my average. You will be going for my average. You are not interested in my score in each subject. You are just interested in my whole academic performance system as a whole. So you go for the average, right? Why I'm discussing average is very important, because center of mass is some kind of average, right? So there are two kind of averages. One is simple average and one is weighted average. One is simple average, other is weighted average. Okay, simple average means if suppose in your semester you have A, B, C, D and say E, these are the subjects. If these are the subjects and you score, let's say 80 marks, here you score 70 marks, here you score say 60 marks, here you score let's say 75, and in one other subject you score say 90, let's say 90. I've given you good marks basically, right? So you have the 5 subjects, and what is the total marks? It is 80 plus 70, 150, and then 210, and then 300, and then 375, right? It's 375. And how many subjects? You have 5 subjects. So what is your total score? It's 7 and I think 5, 75%. Your score is 75%. Your score is 75%. So you can see that all these marks have been here and there about 75. One was 75 itself, other was 70, so there has to be some 80. If there is some 60, there has to be some 90 also. So it's there. Overall marks was here and there about 75, here and there about 75. So this is what we have calculated is simple average. I have calculated simple average. But usually in colleges, some of the colleges where I studied in IIT BHU. So there we had credits, like if suppose you are physics students, nowadays we have a culture of some interdisciplinary courses, like physics students are made to study psychology. They may have a subject called psychology, or they may have a subject called, say, English, right, technical writing. So if suppose these three subjects are physics subjects, like say one of is mechanics, other is EMT, other is quantum, so they assign credits, like say they have assigned credit of say 4 credit over here, they have assigned 4 credit over here, they may assign 4 credit over here, and this is say not a very important subject, say it is psychology, so it may have say only 2 credit, and this is say English, so you have 1 credit only, depending on the importance of subject. Basically, usually in our university system, 4 credit means you have 4 classes in a week, 4 classes in a week, right? So it may be tagged to some kind of thing like number of classes per week, or say importance of the subject. It may be, it's not hard and fast. It depends on importance of the subject which student have in the curriculum. If you are a physics graduate, if you are doing graduation in physics, then the subject which is related to physics may have a higher credit, and the other courses which are not a part of physics as such, like psychology, English, may have a lesser credit, right, depending on the important subject which you have in the course, right? So assigning credits means assigning something like weights. We assign weights to the subjects. We assign weights to the subject, and then your person is calculated as 18 to 4 becomes 320, into 4 becomes 280, into 4 it becomes 240, and into 2 150, into 1 say 90. Okay, so what marks? You just sum them. What I am doing is I am calculating weighted mean, or weighted mean. I am calculating weighted mean, right? So weighted average, I am calculating weighted average, because each subject are not all the subjects are not equally important. When all the subjects are not equally important, you go for weighted mean. Means these subjects are important, so higher marks in this subject means better academic performance, right? If all the subjects are not equally important, you go for this kind of mean, weighted mean. You assign weights according to this importance. According to the importance, you assign weights, and you calculate this kind of mean. So this comes to how much? 600, and this is 840, and 90, 840 plus 90 is 930, and plus 150 is 1080. Please check, it's 1080. So you just sum, just multiply by the credits. You just multiply by the credits, get the total marks in each subject, add them up, and divide them by some of the credits. 4, 4, 4, 12, and 2, 14, and then 15. Okay, so this will come out to be how much? This is 7, and then 2. It's 72%. Weighted average is 72%. Weighted mean is 72%. Okay. So what's the difference between the simple average and weighted average? In case of weighted average, those subjects which have higher credit, the marks in those subjects will be affecting your mean more. The marks in the subjects which carries higher weights, higher credit, will be affecting your average more compared to the subject which has lower credit. Like you got 60 in a subject which has 4 credits, your marks went down. You got 90 in a subject where you have credit 1, so this didn't affected your marks so much, right? So overall average went down because those subjects which carried more weights, you scored a bit less, like 60. This affected your marks. This affected your marks a lot. This didn't affect your marks a lot. The importance of, you got 60 over, you got 90 over here. So if it would have been a simple average, this would have just balanced. Scoring less in this and scoring high in this could have balanced your marks, but then when you go to weighted average, scoring 90 over here, scoring 60 over here is not balancing each other, right? You have higher credit assigned to this subject, you have lower credit assigned to this subject, right? So in weighted mean, the subjects which are more important, the marks in those subjects is affecting your overall marks more, right? You are seeing that. So that's the weighted mean. That's the weighted mean. See, you may be thinking that why I'm discussing all these things, because your understanding of these mean is very, very important to understand center of mass. I'll come to it. So this is weighted mean. This is weighted mean, right? Now let me say, like in my college, I am B.Tech in Electrical Engineering. We used to have B.Tech project, and that used to carry the credit of 8. Let me tell you, I was not very good at electrical engineering. Our B.Tech project carried 8 credits. So we were very careful. We were very, very careful in the subjects. We used to always say good morning, good afternoon to my professors under whom I was doing B.Tech project. So because B.Tech project carried 8 credits. So getting low marks in this subject will affect my average in a big way, right? And we had one subject called technical writing. It was English subject, and it was carrying only 1 credit. One madam used to come and used to teach us this subject. We rarely attended. Sometimes we didn't attend this class. Like carrying 1 credit was not affecting much. So people used to easily leave this class and sleep in the hostel and all that, right? So since it carried only 1 credit, people used to pay less attention to the subject, right? Because marks in this subject was not going to affect much. It was subject E basically, right? So the subject which were of higher credit, we were more serious, because marks in those subjects is going to affect it more. Subject which was carrying 1 credit, people were less serious. Like if it is very hot, it's a severe winter, you can leave the class, right? Be in the hostel and enjoy your stay in the hostels. Don't attend the class of single low credit. So we used to do that. I don't advise you to do that, right? So now let me take a strange case. Suppose I assign, let me delete this. If suppose I assign 100 credit to this subject, I assign 100 credit to this subject, what will happen? If I assign 100 credit to this subject, then you will stop attending the class of this subject. People will stop attending the class of B, C, D, E. Why? Because your average marks is the marks which is scored in this subject only, 100. Subject A is carrying out extraordinarily high weight. So it not only affects, it decides the average. A decides the average. The marks in A is going to be the average. Marks which you score in A is going to be the average. These subjects are not going to affect. So people will stop attending this subject. They will only concentrate in A. That's why we never have this. But then this is an extraordinary case. This is an extraordinary case, strange case, where if one of the data is given extraordinarily heavy weight, then the marks in that subject is going to be the average. So this is weighted mean, right? So you understand weighted mean. Now let me come to center of mass. Center of mass. I define center of mass as weighted average of position of all particles. Like if suppose I have a 3-dimensional system, say XYZ, say it is XYZ, and you have a say particle M1, particle M2, say M3, Mi, and say Mn. Say this is Mi, this is Mn, right? So these particles, the positions are described by, let me use blue pen. So suppose the positions are described by these vectors. Suppose these are the system, these are the particles, and I have described their position. I have a system of n particles, say R3, Ri, Rn, and R2. So if I am interested in motion of the system as a whole, if I am interested in motion of the system particle as a whole, I am not interested in motion of each particle. I am not interested in motion of each particle. I am interested in motion of the system as a whole. In that case, what should I do? If I am interested in motion of the system as a whole, I am not interested in motion of each particles, then what should I do? What I can do is, or what I should do is, I should calculate average position of the whole system. I should calculate some position which can give you the average of all these positions. Some point which should be the average, the position of this point should be average of the position of all these masses. So it can be say R1 plus R2 plus R3 plus Ri plus Rn upon n, simple average? No. In mechanics, the importance of the particle is by its mass. We have seen everywhere, almost all the physical quantities depending on mass. Acceleration depends on mass, momentum depends on mass, energy depends on mass. So mass play a key role. Mass play a key role in deciding the physical quantity associated with the bodies. So mass, the importance of particle in physics is by its mass. So all the particles are not equivalent. So position of all the particles are also not equivalent. Position of all the particles are not equivalent. All these particles are not of equal importance. If I decide something about a system, say let's say kinetic energy of the system, then the kinetic energy of a particle which is having large mass is going to contribute more to the Ke of the system compared to the particle which is having a smaller mass. So in mechanics, the importance of the particle lies with its mass, right? The one which is heavy carries more importance, is contributing more to the physical quantity associated with the system. So the importance is by its mass. So the simple average won't do. We have to go for weighted average. And weights must be proportional to its mass. Weights must be proportional. Weights assigned to the position of each particle must be proportional to the mass. So what I can do is, I can go for the weighted average, like say M1, R1, M2, R2, M3, R3. Similarly, Mi, Ri, Mn, Rn upon M1 plus M2 plus M3 plus sum of weights Mn. So this can be the weighted mean. This can be the weighted average. This can be the weighted mean of the position of all the particles. And I call this position a center of mass. This is your center of mass. I call this center of mass. Getting a point? So this is going to be the average. I should write like this. Yeah. this is going to be center of mass, right? This is going to be the center of mass, the weighted mean of the position of all the particles forming a system. Weighted mean of the position of all the particles forming a system. Now, I'll tell you one more property of a mean. If suppose your mass in say 10th class, 10th standard was say 90%, right? And marks in 12th was say 80%, say, suppose you are a good student. The average means, see, 90% means 90%, 90, the marks 90 is going to be, means the marks in all the subject will be here and there about 90. Marks in all the subject will be here and there about 90. This 90 can't be less than, say, your marks is say at this 90 will be within the marks obtained by you in each subject, like say it will be 80, 95. See, let me tell you. See, what I want to say is, if you score 90%, this 90% is within the data. Within the data means, if you have scored marks say A, B, C, D, E, then this 90% will be lying within this A, B, C, D, E. If the lowest mark you score, the lowest marks and the highest marks in some subject, you'll be scoring the lowest marks. You have a range of marks, say it is 75. Say your range of marks which you score is say varying between say A to B. This is the lowest marks you score, this is the highest mark you score in one of the subject. Then this 90 cannot be less than A, and this 90 cannot be more than B. Getting a point or not? See, you have 5 subjects and the lowest marks which you score in any subject is A and the highest marks you score in any subject is B. Then your average marks cannot be less than A, the average marks cannot be greater than B. It has to be somewhere between A and B only, right? Means the average lie within the data. Average is the measure of central tendency. Suppose you are riding a vehicle and the lowest velocity you attain is 20 km per hour and the highest velocity you attain is 80 km per hour. Then, and you move a distance of say 200 kilometers and the lowest speed you had was 20 km per hour and the highest speed was 80 km per hour. The average speed which you get won't be beyond 80, it won't be beyond 20. It won't be less than 20, it won't be more than 80. It will be somewhere between 20 and 80 itself. Getting a point or not? So it means, if suppose I have say this system of mass, this system of particles, my average will be somewhere within this envelope. My average is going to be somewhere within this envelope. If I draw a region, I draw a volume which is containing all the particles, my average won't go out of it. My average will be within the system itself. Average will be lying within the system itself. It won't be lying like outside M1, M2, this enclosure. It will lie in this enclosure. So, suppose, that's one thing which is very important about the average. Any average, be it simple average or weighted average, right? Weighted average will be closer to the particle which is having higher masses, right? If suppose these M1, M2, M3 are having higher masses compared to M2 and all these particles, so weighted average will be more closer to these particles compared to the lighter particles, right? So that's center of mass. So what we do is we try to study the motion of system as a whole by studying the motion of center of mass. We try to concentrate all masses, capital M. I write capital M over here. Notice capital M. Capital M is sum of all these masses. We say all the mass is concentrated over here, and what I do is I try to study the motion of this center of mass. Right? What I do is, in order to study the motion of overall motion of the system, I am not concentrating myself on motion of individual particle. What I am doing is I am trying to see how this average has moved. Like you saw my average, I scored 89.8, then I scored 79.4, then I scored 7.4. What you are studying? You are studying how my average is moving. In the same way, you will be studying how the center of mass is moving, how the average position is moving, and that will give you a good idea about how the system is moving. Suppose after some time your system, say, it will have all this. So suppose after some time your center of mass has moved from here to here, say here. Then it means if center of mass is now this point, then all these particles must be here and there about the center of mass, right? All these n particles must be here and there about center of mass. It can't happen like center of mass is moved and this particle will remain here. No. If center of mass, after some time you find the center of mass has moved to this position, means all these masses must be here and there about the center of mass. All these particles must have moved. Like say, you have solar system. You have solar system. I'll come to solar system later on. That's a very special kind of system. Okay. So the center of mass, if you study, if you get to know how the center of mass is moving, then you are getting an idea how the system is moving, because as the center of mass moves, this particle will always lie here and there, because I told you center of mass has to be within the region. Center of mass lies within this envelope, so this envelope is going to shift like this, right? Center of mass is moving, the whole envelope of this is going to move. This envelope contains all the particles. So center of mass is moving means all these particles must be lying here and there. So these particles have also moved. Means if my mass has fallen from 90% to 80%, means overall mass has fallen from a 90% to 80%, means my mass individual subject must have fallen. Now it is here and there about 80. Earlier it was here and there about 90. Alright. Okay. Sorry. Okay, so that gives you a good idea. So it's enough if I want to study the motion of the system. I think it is enough to study the motion center of mass. That will give you a better idea how the system is moving, right? Now, sometimes in this system of particles, one of the body extraordinarily heavy. Sometimes you come across a system where one particle is extraordinarily very heavy, like solar system, right? Like solar system. One of the particles, that is sun, is extraordinarily heavy. So what happens when one particle is extraordinarily heavy? Suppose your M1 is extraordinarily heavy. M1 is very, very heavy compared to the other particles. In that case, what is your center of mass? Center of mass was M1R1 plus M2R2 plus MI-RI MNRN upon Mn. So this comes to be, if I divide numerator and denominator by M1, I'll divide by M1, Mn by M1 Rn upon say Mi by M1. See, if M1 is very large compared to other particles, M1 is extraordinarily heavy, in that case these terms will tend to 0 and your RCM is nothing but R1. See, if M1 is extraordinarily heavy compared to all these masses, then for all practical purposes your center of mass is going to lie on M1. Center of mass is going to lie on M1 and other particle will be here and there about M1, right? So in that case center of mass for all practical purposes lie on M1 itself, like say solar system. in solar system, mass of sun is very heavy, mass of sun is very large, extremely large compared to mass of other particles. So for all practical purposes, center of mass lies on sun. So if you are interested in studying the motion of solar system in a universe, you don't have to do much labor. You just study the motion of sun, because other planets will be lying here and there, right? Because sun is extraordinarily heavy compared to other particles. So in that case, sun, the center of mass of the solar system for all practical purposes, is going to lie on sun itself. So you just study the motion of sun, you'll be studying the motion of the system. In earlier days, when we used to have monarchy, the kings, still in many countries you have kings, unless we have president or prime ministers. When kings used to move in the city, or when they used to go for some recreation, they used to be surrounded by many people. Somebody used to blow the pipe, somebody used to sing, or somebody used to play some musical instrument. There are people who were carrying the flags. They were the people who were the bodyguards. They were on the horses, and the king used to be on the elephant, right? So king is surrounded by 100 people. King is surrounded by 100 people. Yeah, 100 people surrounding the king, say. So if I ask you, if I want to study the motion of that group which is having a king in itself, a group of people where one of the person is king, then can you tell me whose motion you should study? If you want to study the motion of that group, whose motion you should study? It's king. Because you know that if I see the importance of the position of all the people over here, the king, the motion, the position of king carries extraordinarily high weights. King is the most important person in that group. So he carries extraordinarily high weights, right? So for all practical purpose, the center of mass of that group lies on the king itself. Center of mass of the whole group lies on the king itself. So it's enough to study the motion of the king. That will give you how the group is moving. That's the case when you have some very, very important person in a group. So all the eyes are on that very important purpose, on the very important person, right? If suppose we have 100 people and one of us is a prime minister, right? Then he is most important one. If somebody want to study the motion of my group, he will be just considered as a prime minister, right? Because he is a person having extraordinarily high weights. So the whole center mass, the whole group of people lies on the prime minister, PM, right? So it's enough to study his motion. That's what the center of mass is actually, right? In the same way, in the solar system, sun is the king. Sun is the king. It's enough to study the motion of the king itself, right? So that's how you understand center of mass. This is extremely useful when you are studying most of the system as a whole. When you are studying motion of the system as a whole, you are not interested in motion of each particle. You want to study the motion of the system. Many times we come across such a thing. Then you don't have to waste your labor. You don't have to waste your time studying the motion of each particle, which will be very complicated at times. Just study the motion of the center of mass. And in next lecture, I will tell you how do you study, what are the equation which governs the motion of center of mass. Which equation the motion of center of mass will be following. What is the law of motion for the center of mass? What is the equation of motion for the center of mass? Right. So I think you understand. It's a very lengthy lecture.